reverse engineering of locker ransomware, and it's DR Studies Security Operations Analyst at SpectroBlood. Please give him a warm welcome to the stage.
So, small details about me. I am DR Sadi Ali. My role is at SpectroBlood as Security Operation Analyst and Independent Researcher. I am also the cybersecurity consultant at Kurdish UK Association that I am fighting cybercrime and child predator in the digital space. And also, I am author of the 2 books regarding to digital forensic and media contributor overwriting your LDR record. In this case, until you have a key or you pay the ransom, you're not able to get your systems back. So there are a great question. The ransomware, the ransom locker is actually a ransomware. The answer not. The ransom locker is not a typical ransomware because in some cases, the ransom locker, it doesn't encrypting your data, but it have some functionality that a normal ransomware is locking your device and make your device inaccessible. That's a short amount and definition of the difference between ransomware and the ransom lockers. So how the ransom locker is work? So the overwriting your LDR record. In this case, until you have a key or you pay the ransom, you're not able to get your systems back. So there are a great question. The ransomware, the ransom locker is actually a ransomware. The answer not. The ransom locker is not a typical ransomware because in some cases, the ransom locker, it doesn't encrypting your data, but it have some functionality that a normal ransomware is locking your device and make your device inaccessible. That's a short amount and definition of the difference between ransomware and the ransom lockers. So how the ransom locker is work? So the ransom locker, the key is stored inside the software itself, or sometimes threat actor dropping a text file or document file that contain a decryption key. But because you are not able to access your device has been locked. So then the key is locked, the program is checking for the key. If the key is corrected, it's unlocking your device. If not, in some cases, it's overwriting your master boot record or destroying your device. So actually, the process of our analyzing is the initial sample that we have, and then we go into basic static analysis and reverse engineering the sample, and then documentation and reporting. Well, that's a basic static tools that we can use it for our investigation. One of them is Detect Easy for NFL detectors, PE Studio and BTECS. So PE Studio and for NFL detectors and Detect Easy is mostly for basic PE analysis. It's for portable executable analysis. And the BTECS is for string analysis because sometimes just by dumping the string, we can find the specific decryption key for this sample. And for tools of trade for decompiler C# and .NET, VB.NET Visual Basic, it could be DNSpy or ELSpy or the .pip. In our cases, we will use the DNSpy to reverse engineering the ransomwares and find the decryption key. And also for the malware, so the most of the ransomware is not only .NET based, they use a C, C++ assembly. So in this case, we needed this assembler. The tool like IDA, Radar GUI, and Ghidra. The IDA is a commercial one, but the Ghidra and Radar is open source and free. Well, first of all, we got an initial sample. It's a ransomware that is based on the VB.NET and designed to 32-bit GUI. So based on that, we know that this malware can work also on 64-bit operation systems. After that, we open it into the hex editor to validate the PE headers. It's an MZ. So actually, the .exe, .dll, and we have some import API function. That's very important because actually through the import API tables, you can interact with the kernel. So actually, if you have the information in a Windows internal, you cannot directly access the kernel, the ring 0. You have to use some APIs, then connect to NTDLL and then go to the kernel. So in this case, there are some download file, download data, TCP client, registry key, and the enable window, and the others APIs that may be used for process enumeration and getting the information about the entire system. There are some APIs that are used by ransomwares, like a crypt hash data, crypt private key, an encrypted file, a crypted decrypted. That's this API tables is very important for malware analysts to have the information, because actually malware analysis tools mostly are outdated, and we have to have an eye detection, pattern detection based on our knowledge and experiences. Well, actually, we have the packer. What's the packer doing? We have three types of the packers. Packer is a protector, and compressor, and encryptor. So packing is actually what doing, it's making the strings and other data unreadable. So it makes our security analysis process is more harder. So we can actually detect the packing only by the section name. For example, in this case, the attacker using AS packer, and in this case, the attacker using the UPX. That's ultimate packers and compressor for abnormal and abnormal software. Well, let's go to reverse engineering actually. In here we have an explorer, we have a decompiler codes, and we have a debugger, tracker, and watchdogs. In here I'm importing the Nebula word into the DN spy and go to the entry point. And actually that's all the extension that ransomware is starting to encrypt, like VMware files, like video files, Excel files, and backup files. And even it copies many extensions, wallet's and other stuff. So actually here, what this malware is doing is match on the Nebula, it will decrypting your file. Like if the DW, that's new password, matches the password variable, and the password variable is what? Is Nebula, that means your file will be decrypted. Like this one, that we have it, that's our extension Nebula, and that is, we match the password and our file and our entire system will be decrypted. And thank you for listening. If you have any question, please ask. If the text box is equal to this base 64 encoded data, that means the key is corrected and it's unlocking your device. Here actually we have a ransomware, HTML.dll, and for some boxes like a SBE.dll. So based on that, threat actor will check in for this DLL, and if this DLL file is available on your operation system, the malware starts killing itself, self-destroying it. So actually, we have drivers, to assist driver for annual sandboxes. I have many techniques to detect annual sandboxes. Well, actually, there are another technique, the malware nowadays checking for the tools. If the Wireshark, Process Hacker, Process Explorer is in your tools, like IDA Pro in your tools, malware checking for it and start killing itself. How does it work? Here, it's a create a while loop to get a process information and the PID and the name that matches to these processes, the malware start killing itself. That's a process of malware termination processes. And in here, malware is doing the persistence mechanism. What the persistent mechanism is? Persistent mechanism that's a way attackers can return on your system after restarting your device or a later time. So the attacker in here performing the persistence through the registry, run key, and also from the task schedule. So actually the attackers, some of the ransomwares have the worm mechanism that's spread through the USB devices. If you plug a USB device on your computers, it will check for the removable device, and if the device is already infected, it will leave it. But if not, it starts infecting your USB drive, and when you plug the USB drive on the new computer, again this new computer also will be infected. And actually here, ransomware is trying to do using the ping command, cmd.exe, ping and 101 -n, that's a timeline. After 5 seconds, the initial samples will kill itself, will destroy itself. That means you are not able to get the main samples and reverse engineering it to get at the decryption key. In the modern malware, after infection, the malware starts killing itself direct on the DNS. Even if you are using the most query, you cannot able to find the deleted, maybe only from the privilege file in the forensic perspective. And here is actually attacker is disabling Windows Defender, and put their own sample into exclusion in the Windows Defender. When you put your software on your exclusion, that means the Windows Defender skip the sample to analysis. That's make detection more harder and more harder. And here, where the key is stored, remember, mentioned some ransomware is storing the decryption key inside itself. Look this one, I have this ransomware lockers, and that's a key. Because the user doesn't have access to their own computers, he or she not able to get the access on the file, he have to only wait to pay. But actually I have a tool called CMD Watcher to get the files here. That's a key. That's a key available from this file. So that's why some ransomware lockers are different. So actually you can also detect the decryption key through the string analysis. Here we have the message box it mentioned incorrect key. That mouse and keyboard is, and here the attacker is getting the source of the wallpaper and change your desktop string while infected by the ransomware. And here is start for VM checking. So modern malware is start for your environment. That it's actual machine, was machine, or it's a virtual machine, or it's a sandbox. So in this case, the attacker using WMIC Windows instrumentation to checking your system information, like a CPU, MAC address, IP address, and so on. And how it does work, in the normal system, it mentioned that a Windows user, that's a normal system. But actually, the other system is a virtual machine. So if the malware is a virtual machine, start terminating itself. So it starts killing itself and does not continue to infecting your device and encrypting your data. So actually, that's anti-sandbox mechanism that malware is using. For example, VM test for VMware